Hello. Welcome everyone. Today is again Sunday and we're again in Microsoft Office, and today we're again streaming. So let's see. Hi guys, great content. Is there a secret or formula to what you do? I'm not sure I'm doing any great stuff, so I'm not sure there should be any secret. Yes, so hello, have a great stream. Thank you. We will have so what about the agenda for today's stream? Basically today I would like to focus more on the system design and implementing our rate limiting API, scalable, reliable and stuff like that, rather than solving a lot of LeetCode problems. So most probably we will focus exactly on this. We're gonna be focused on the system design. So I think now we're just gonna solve, or maybe even not that. Yeah, this was the previous question. Yeah, this one. Yeah. So our LeetCode questions are, I think, is these three for today. I wouldn't spend more time. And then back to our rate limiting system design. Maybe you remember previous time we were doing system design of like the basic stuff, design a rate limiter, right? We implemented it somehow. We designed some workable solution. Of course, it's not the best. There are many trade-offs, and interviewer might ask you for different trade-offs. But I kind of assumed a lot of stuff here, right? So we were using the algo called fixed window or something like that. Whenever you have some timeline of the time. And basically the algorithm for rate limiting in this case is, let's assume your boundary is 100 requests, or for simplicity let's put like 3 requests per second, and you split your time by seconds. So here's 1 second, 2, 3. This is monotonic, right? It always grows, and you implement your algorithm in the way that each of these sectors can have exactly 3 requests per second. So this one can have 3, and force would give you 4 to 9. Too many requests, wait a bit longer. So this is what we're going to implement today. More specifically, yeah, since it's scalable, reliable, blah blah blah. Today we are not going to do it in JS. I'm gonna use .NET, my main language that I started, and I think I'm the most proficient among all other languages that I tried so far. So we're gonna implement this part, rate limiting API. We're gonna implement, I think, 2 parts of it. So first one, we're gonna do it in memory, and second one, which is actually better, but yeah, for memory we still should implement just for showing purpose. And the second one is for Redis. Yeah, we will pack it into the Docker and run some K6 load testing to ensure it works as expected. Yeah, so this is the plan for today, at least. And yeah, also before that we're gonna solve a couple of LeetCode problems, because yes, preparation to interview should be going. So this is basically the plan. Let's go. So today's topic is stack, right? It's removing stars from a string problem. Let's see. Good. So the problem, removing stars from a string. We are given a string which contains stars, and in one operation I can choose a star in string and remove the closest non-star character to its left, as well as remove the star itself. Return the string after all stars have been removed. Input generated operation is always possible. The result string will always be unique. Okay. So what they are asking us to do, let me take this example and draw it here. So I think in our case it's better to consider it as an array. We have lit then 2 stars, then COD, then again 1 star, and then E. So this is our string. Nice. What they're asking us in the problem. So we need to remove, whenever we meet or encounter any star, we need to remove the closest non-star character to its left. So in case we are iterating the array, we met 1 star, we need to remove previous character to the left, non-star character. Then we meet another star, we remove previous one, like that, then it's okay. Letters we can skip and keep traversing. Then another star, we meet it, we remove previous character, and this is the resulting string. Oh, sorry. This is the resulting string. LeetCode in this case. So how gonna we do it? Exactly using the stack, since this is the stack problem. It's pretty easy. I don't think it should be medium actually. So let's paste our problem here. Yeah. So what we're gonna do, we're gonna introduce the stack in JS. I think the easiest way how to do it is just use the array. And what we're gonna do, actually, let's first introduce. So stack is gonna be represented as an array. Then we want to traverse the whole string. Oh, there is copilot. Good. I don't like the copilot actually. I don't like it shows the response, because copilot, I think there is for sure some public repo with all the answers for all LeetCode problems, so I'm gonna turn it off. Either copilot. Can I uninstall it somehow? Please. Disable restart extensions. The best part about Visual Studio Code is that you can enable and disable your extension and you don't need to restart the Visual Studio Code. This is the best part of the Visual Studio Code. Whenever I'm doing something in Visual Studio Rider or whatever else, always when you update some plugin or install some bullshit for your dev experience, you need to restart this IDE, and usually I'm working with pretty big projects on a production, so it takes like 5 minutes to load again and to update all the indexing and stuff like that. So good. So we are iterating the string, and every time if it's not the star, we just put this character to our stack. So if si is not equal to star, we're gonna just put to our stack, or just put it to our array. But if it is star, what we should do from our example, let me put back everything like it was before. So this is our stack, and we keep iterating. We are putting every letter while we are traversing if it's not star. Then we meet star, we remove this letter, and we just don't put star to the stack. We again meet star, we remove another letter, and keep going like that. And this is algo. So whenever we meet the star, we just pop the last character from our stack, and that should be the solution. Stack pop and return stack. Now, should we return the string or not? Yeah, we should return string, but since our stack is an array, we're gonna do join. Exactly. Let's run it. What? Ah, yeah, sorry. Yes. Good. The complexity time in this case, let's consider it. And so time complexity in this case would be, we're iterating through the whole string, which is n already. Yeah, these are constants. The popping from the end of the array is constant time operation. And then we are doing joining array to string, which most probably is O of n as well. So this is O n plus n, which results in O of n. And regarding the extra space, it is O of n since we are using the stack, or maybe O 2 times n since we are converting it to the string in the end. So O of n solution. Good. Pretty much easy problem, to be honest. I don't think it should be medium. Good, so let's go later. Okay, just check the stream. Seems like going good. Now, another topic, another problem. Asteroid collision. This one is a bit more interesting and I think a bit more harder. So we are given an array of asteroids. These are integers representing asteroids in a row. The indices of the asteroid in array represent their relative position in the space. Good. So for each asteroid, the absolute value represents its size. And the sign represents its direction. So positive means it goes right, negative meaning left. Each asteroid moves at the same speed, blah blah. Okay, so let me explain from the example. I like it to be visualized a bit more. So this is our example. Let me turn off the notifications. I think our on-call person is fighting some incident right now. So yeah. Okay. So this is the example. So we have 5, we have 10, we have -5. So the value itself, the absolute value, numerical value, is the size of the asteroid, which is basically its weight. And the sign near this number is the direction of asteroids. So they are constantly moving, they are not at the same spot. We also have it in the constraints that, yeah, this number cannot be 0. Because if it's 0, it means the speed is 0 and it stays at the same point. So if you have 5, it means it moves to the right always, and its size is 5. If it's 10, it moves to the right as well, same constant speed, but to the right, and size is 10. If it's 5, if it's -5, it moves to the left. So if these two moves to the right and this moves to the left, at some point 10 and 5 would collide and explode. And since 10 is more than 5, 5 is just dropped, and these two continue moving, and this will be our resulting array. Pretty cool problem, to be honest. If the size is the same, they explode and cancel each other. Yeah, and if one of the asteroids has bigger size, it just kinda eats another one. So in this case, 10, 2, -5. So 10, 2, -5. So in this case, 10 and 2 moves to the right, -5 moves to the left, 2 and 5 meet each other, and 5 wins because -5 is more than 2, 2 is out, then it moves again, they meet each other, -5 is less than 10, -5 is cancelled, 10 is the result. Pretty interesting problem. So how I can approach it actually? And the approach is the following. So we have 5, I think, 5, 10 minus 5, yes. So what should be the approach? In which case, let's just brainstorm it. In which case we can safely traverse this input string and be sure that we can safely add it to the output array, and like the asteroids will not explode. So asteroids are not exploding in couple of cases. So first one, both of them are positive. It means that both of them are just moving to the right all the time, constant speed. They will never meet each other. Another thing, another case I would say, in case we have the following case. So this one is minus 15 and the next one is 2. So minus 15 is larger than 10 and 5, so it will drop them. And yeah, this is the beginning of the array, so minus 15 is already, and I cannot go further. So it stays in the output, and then the next one is 2, but 2 moves always to the right, and minus 15 moves always to the left. So they will not meet each other, and we can safely add it to the response. And this will be the valid response. So the only case when they can meet each other is actually when the left one is moving to the right, and when the new one is moving to the left. So these kind of things. So the left number is positive, right number is not positive. How I can do it? It also should be done via the stack. We cannot just do it with the last number while we are traversing, because in this case, whatever we have here, it does not matter. 15 will cancel all of these numbers because it's bigger. So we should keep canceling and popping from our stack these numbers up until we reach the beginning, or up until we meet some bigger number than minus 15. Sir, can I ask a question? Yeah, for sure, go for it. This stream is specifically, it has label ask anything, so you can basically ask anything. So the solution. We again should do it with the stack. So let me try to implement it. Stack is kind of natural thing here, because at each point of the time, we actually do care about the last element that we just processed and new element that we're going to process from the input array of asteroids. So whenever we added something here, we kind of can sure that it should stay, and whatever is left in the stack, it should not collide. And the new item can basically mess up these previous items. But no matter what, like if this 2 is in input somewhere here, yeah, let's assume this case. So this is the input and this is our stack. So in this case, whenever we got 15, we just check in 15 and 10, yeah, it cancels 10. Then we check 15 and 5, it cancels 5, and etc., etc. And we're just going up until we reach the beginning or bigger number. That's why the stack. Like, it's kind of convenient from the runtime perspectives, because popping and pushing to the stack is constant time, right? So that's the thing. Okay. So yeah, we are starting with stack. We should traverse all the asteroids, right? So let's try this. I don't think we need index here. Yes, asteroids, just for each, right? And then what I'm gonna do, every time I meet the asteroid, I'm putting it to the stack. And then I'm just working with the stack. I don't care about the input anymore. Like it decreases cognitive pressure, kinda. So we are putting asteroid. And then we are working with stack. So we are checking if it's not empty. And then we actually want to do our stuff exactly with two items, the new one that we just processing and the previous one. So basically I think this condition should be changed. It should be more than one. If it's just one, we kind of skip, we cannot process it, right? Nice VS Code theme. What is the name of it? This one is called Nordic, I think. Right, Nord. Yeah, this one I installed. Yeah, pretty cool. I have to agree. It's pretty cool. Sorry, there may be a delay, but the question refers to the first problem, but I forgot and I don't want to slow you down. No problem. No, no problem at all. You can ask, like, even for previous question, it's all right. So yeah, now when we have our stack that has more than one element, we can just safely pop both of them. So the first one we are popping is the current one that we just pushed. And there it's previous. We are popping it again. And now let's straight away check the case when we kinda should not do anything because nothing will explode. Which are these cases? So if current is more than 0 and previous is more than 0, this is the first case. Oh, okay. Let's decouple it to variable. If both of them are positive, we just don't care. They both move at the same speed, same direction, or they are both negative. In this case, we also don't care. This is the example when we have -15 and -2. So this 15 will cancel out every single positive number before. Then we have -2, and yeah, these two just moves to the left with the same speed. We don't care. So if previous or current less than 0 and previous less than 0, and one more case when they both move into the different directions. So when previous moves to the left, so it's less than 0, and current is more than 0. This is the case of having -15. This is our previous N2. So this one moves to the right and 15 moves to the left. They will not explode anytime soon. So if should not explode, what should we do? We should just return back our items because they are valid items. We want them in the input. So stack push previous, stack push current. Then we will optimize this algo a bit later, but I'm just putting the idea first. And then we continue. Oh, sorry, we are not continuing. We actually should break. We are breaking this while inner while, and we start in the next one with the new asteroid. But what if they do need to explode? So this is the case when the previous is positive and current is negative. In this case, we just need to understand which one is the bigger, and the bigger should stay in the output. That's the basic idea. So in case, but yeah, there is one more example. When they are equal, then they cancel out each other, and we just should straight away stop processing. So let's first process this this specific case. In case previous equals minus current, then we break, because we already popped them and they are not in the input anymore. But what if they are not equal? Then we should decide which one is bigger. So if mass absolute number of the previous, no, actually should be minus previous. Yeah, so current is less than 0. It should be, according to this one. So current is less than 0. So yeah, I think this makes more sense. However, the other way around, it also should be true. So if our previous, if our current, because current is less than 0, bigger than previous, then it means we are pushing current. Otherwise, we are pushing the previous, because it's bigger. And after that, yeah, the loop is done, and we keep processing another one asteroid. In the end, we just should return the output stack. Let's try this solution. Yeah, it passed, but runtime would be a bit bad, and I would explain later why we will optimize it. Yeah, so runtime is not that good. Let's analyze the complexity here. So we're iterating every single asteroid, which is O(n). O(n). This is time. For space, I can tell you upfront it's O(n), since we are using extra space with this stack, which worst case can be O(n). Then, once we are traversing every of asteroids, this inner while true is a bit tricky, because yeah, when you see nested loop, whatever it is, for, while, doesn't matter. Natively, it seems like it should be O(n), right? It should be O(n) power of 2, so n squared. Naturally, it feels like that, but in this case, it's not, because actually, once we put the element to the stack, in worst case, we can touch it only once more. So worst case, once we put all the elements here, let me go to this case, yes. So current item is minus 15. Before that, we processed all the items, and let's say we were just adding them according to our algo. This is 4 operations so far. Now we are currently minus 15, and we're touching each of them once more. We are popping them out from the stack, and then it's minus 15, and we will not touch them anymore in this algo. So these items are done. We will not traverse them anymore. So at most, we can touch every single item from the input array twice. First time whenever we are putting it to our stack. Second time when we are popping them out forever. Other than that, once it's done, all previous items are set. We will not touch them anymore. We will keep just processing and processing again. But why then our time complexity and runtime in this case is so long? It's 8 milliseconds, so I don't think it's pretty random. it will be always like that. Actually, the problem is that we always, while we are performing operations with the stack, we always do 2 pops, which is kinda unnecessary in this case, because previous item should not necessarily be popped. Why? Because in case we should not explode, we are just putting both of them back. So actually, we don't need to pop both of them, because stack, okay, in JS it's just array, but naturally stack has pick method, which just gives you the value of the last element that you just inserted, and there is pop method, which returns you the value and removes this value from the stack. But we cannot do 2 picks, right? For like in this case, we need current and previous value. In the JS, we can do it. It's length -1 and length -2. But in traditional kind of stack, we can pick only the last number usually, how it's implemented. So previous, we can move here. And let's say we are popping only the current value, which we just inserted here. And if it should not explode, we don't push previous as well. We just push current that we just popped, and that's it. Previous item should be popped only for the next processing, because we might decide to not push it back to the array. Initially, if we should not explode, we don't even need to pop previous, because we will anyway push it back. This is kind of the logic behind it. It does not change runtime complexity at all, but it will change the runtime on the LeetCode. Well, yeah, so, and instead of previous, since we don't pop it, we can use pick, and in our case, pick is just the last value of the last element in the array. So this should be length -1, this should be stack length -1, and this one as well. Yeah, a bit messy, but can be better, but I don't like nesting. This if can be reversed, but I don't like nesting, and I'm omitting it as much as possible. Good. And now let's see the, oh, interesting, it shouldn't be like that. It shouldn't be like that. Okay, interesting. Last time, as I tried it, the runtime was actually better. Ah, yeah, now it's better. Maybe it's kind of random, but whatever it is. Let's move on. We have the last question before we start implementing our rate limiting system design solution that we system designed previous stream. Yeah, so stay for one LeetCode problem more, and we're gonna do it. So this is interesting problem. This is the code string problem. This is kind of parsing slash compiler related thing. It's pretty interesting. So what we should do, there is encoded string and we should decode it. It is encoded in the way that there is number that says how many times the character in the brackets should be repeating. So if it's 3a, the output should have 3 A's. If it's 2BC, it should be BC, BC. It's gonna be pretty easy solution, but there is some tricky case, which is this one, which is 3 open brackets A with 2C. So this one should be treated carefully. What do I mean by that? Let's put it back. So we have 3, actually it's here. We have 3, and this is the brackets for the 3. Let's separate them. And inside the brackets for the 3, we have actually the first character A and 2 C's, which means it can be nested, and it brings a bit of complexity, because now to be able to resolve 3, we should first resolve this 2C, which will be resolved, in this pretty simple case, to 2 letters C, which gives us ACC, and then we should repeat ACC 3 times. And then we can kind of decode the 3 number. This is exactly the answer. And this is going to be tricky. And this is already feels like stack from the naturally, whenever you learn some parsing compiler related topics, you can naturally understand that, yeah, it is stack. It is stack for sure. But how gonna we implement it? So it's pure string, so we should first parse it somehow understand which operation should go first, and then basically process these operations one by one. So if we are talking about the stack, let's first understand what do we need for our stack to be able to process the items. So whenever I'm in the stack, I'm for sure know 3 elements. First, I need to know the string. This is kind of the string that is in the bracket. So all the time this string should be, let's get some simpler example like this. So we reached 3A, and we know that our string in the bracket is actually A. Second parameter that we need is how many times the string should be repeated. So in this case, it's 3. Basically, with these parameters, we can already resolve 3A to AAA. Same thing happens with 2BC. So string gonna be BC, the number should be 2, and we know that 2 times BC gonna be BC, BC. And then we kind of just concatenate both of these, and this is our answer. Now let's move to this interesting example. So we're reaching 3A. We are trying to kind of parse and read the string value that we want to repeat, and then we reach another term that we should decode. So we should start another one, another this block of parameters. So in this case, it should be string A times 3, but inside here, this string is not actually resolved just to A, but it resolves to another term, which gonna be string C and number 2. And now this is the last one. It is resolved to CC, which we can then return and put it back to this term. And then resolve it ACC, ACC, ACC. And we should understand that this chaining can be any level deep, right? So it can be another one, another one, another one, and we should just resolve it and put the response back, resolve it and put the response back, blah, blah, blah. It can be done recursively, especially with this nesting and returning the result of the subproblem. But the better approach is stack, because it's iterative, you don't have Stack Overflow. So this is what we're gonna do. Every time we are encountering the bracket, open bracket, we know that the term is started. We try to parse the string, and every time we reach and encounter the closed bracket, we know that some term is already done. So we know all information, all 2 parameters to resolve this term, and then we parse all that we previously parsed, so in this case 2C, and resolve it, and then keep processing, putting back to the stack, and then resolve the 3 and term inside. So how it's gonna happen and look like, we have some stack, let's say. This is our stack. So we are adding 3, we are adding then bracket. Let's maybe put it like that so we are not confused. Then we encounter A, it's K, then we encounter 2, it's okay, open bracket C, and then we encounter the closed bracket. Closed bracket means that one of the term, the last one, is already done and we can decode it back. So we are taking every single element up until we parse the number, because the number is the start of the term, we know it for sure. So we are taking C, open bracket, and 2, and once we met 2, and after 2 it's some whatever else, not digit, we know that this is the term. We resolve this term, we process it, we decode it to CC and put it back to the stack. So CC is going to be put back to the stack. And then we keep processing where we stopped. So again, CC, A, and then we encounter the bracket, and then we encounter the digit, and this is the last digit. We know that we know all the parameters we need to decode the string, and we're converting it to ACC, ACC, ACC. This is going to be the solution. Let's implement it. So, first we're going to introduce our stack for sure, and then we're going to do, we want to, yes, we want to traverse our string. So let's introduce some index 0, while index less than string length. We are processing. So we are process character by character in our string. And we already knew the basic the basic algo that if our character, let's define the variable that character is string index, if our character is not closing bracket, we are accumulating the characters to have our term, which is parameter of the digit, how many times it should be repeated, and string parameter. So we're just putting it back to the stack and continue to the next one straight away. Then let's say this character is the closing bracket. Then we should parse whatever we have in our stack. Let me put it back. So let's say we encounter first closing brackets, which is this one. We should parse it all the way up until we reach the character after the digit. So we parse everything and all the digits, because it can be 22 times, right? And this should be separate character, but actually it means not 2 times 2 or just 2. It means that element C should be repeated 22 times. So we are parsing all the digits that we can up until we reach another character. This is exactly what we're going to do. So we need, what's this? First we're trying to do a string, right? And then, then we have sub character. Let's name it stack pop, because before we met this bracket, we for sure had some characters before. And now while this sub character is not equal to open bracket, to this one, we parse it to our inner string. Character and stack pop. Once this sub character equals to the open bracket, we already popped it, so it's not in the stack. Now on the stack we have digits, so we parsing digits up until we meet non-digit character, but we should not pop the last one, so we should not pop A yet. So now we have let num, let's also pretend it's string, we will parse it again. And now when, how how we're gonna do it. Yeah, so this last one is open bracket. So we can for sure do yeah, I think we for sure can do. Yeah, we still want to. Yeah, so let's try this one. While the peak from the stack, which is stack length -1, also it can be the end of the string, so length more than 0 and stack peak. And what we want to, yeah, we should parse it first. So let num character is equal to this one. We want to parse it first. Parse int. And if it's not parsed, it will return none, right? Why it changed to Groovy, I don't understand. So if this number is not int, it should be none. So up until, oh sorry, if it is none, let me show you how none works, because you might forget. So is none, there is function in jest that checks that some character is number or not. So if it's some character, none means not a number. So yeah, pretty weird and confusing name of the function, but whatever. So whenever it's not number, it returns your true, but whenever your string is actually in a number, it returns false. So this is how we're gonna check whether the character is number or not. So if it's none, then it means that we already reached either the, yes, so if it's none, then we're just breaking. Otherwise, if it's legit the number, we're just adding it to the num character, but not in a simple way, because we want our num string come before. Because if it's, let me show you, if it's not 22, but if it's, let's say, 3, first we get 3, we are putting it to our number. We cannot just concatenate the next popped value, which is going to be 2, because then it will make 32. So should it concatenate the other way around. So not num plus num character, but num character plus num. Yes, and in this case we are also doing yeah, we should pop the stack. Now this number is the string representation of the number, so we can actually parse it to the int. So let parse number equals to number parse int number, and that's it. We have our string, we have our parse num, and we should now just reply this string the number of parsed num. But actually for the string we also should kinda reverse it, because otherwise, yeah, otherwise it will not work. It will be in reversed state. So let resulting string is equal, yeah, a lot of different operations are done here. So we're starting from the end. Or actually, yeah, we don't need to do this resultant shit. We know for sure that what we should do is while our num parsed number more than 0, yeah, we should put back our characters. Yes. So whenever we have, like, let's say, what is the example? Yeah, let's say it's 4C. So this is our stack. It's A, 4, and C. We parsed C as a string and 4 as a digit, so they're already not in the stack. And now we want to reply C character back 4 times to the stack. So we do C, 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 like that. And then we keep processing our stack again, but without the nesting at this time. Yes, so once we pushed it back, we are kind of done. And we can, yeah, we should just proceed further up until we meet another character, or if it would be closed bracket, we will do that again. Good. Good, good, good. And in the end, we should just do what? What is asked? Return as a string. So in the result, we will have stack. So I should return stack, join this stack because it's array to the string. Okay, let's see. Most probably it will not work. Let's see. Maybe it will. Yeah. I already see. What did I miss? We should decrease the parse number. Still no. Yes. This is also the reason. Interesting. What is going on here? So index. Yeah, we didn't increase index. So index plus plus should be also in the end. I think it can be even changed to the for loop. But let's first make it work. Before any refactoring, make sure it works. Okay, cool. Now it's undefined because we don't return. Yeah, now it works. All the cases passed. Good. 0 milliseconds, which is pretty interesting. Let's now maybe eliminate this while true. As always, we're gonna do some optimization for like index equals 0, index less than s length, index plus plus. We are eliminating already a bunch of stuff. Is it working now? It's not. Why? Very bad. Good. Should be working now. Can we optimize somehow anything else to make it a bit shorter? Well, we can, I think, optimize this one. So how do you work through your thought process? Well, sometimes it's hard, sometimes I just don't have answer, right? And that's okay. Sometimes whenever I'm solving some LeetCode problem, I just don't have answer. Even brute force. Sometimes There are cases when I reach some LeetCode problem, and even brute force solution, I just don't see it. So in this case, I'm thinking like 1-2 hours. If not, then look into the solution. Yeah, unfortunately, I'm pretty bad at LeetCode. I think this is the worst my part in terms of interview loop. So much better for the interview, for the system design for me. But yeah, usually sometimes you have seen some similar problem, right? Sometimes you just have brute force and somehow you can optimize, but not necessarily I'm doing it 40 minutes, sometimes it's longer. So it really depends, right? It really depends. Yes, so I think subcharacter. Yeah, I think this can be actually optimized if stack length -1, doing this. No, it's yeah, because I should do stack top after, I guess. Okay, maybe we can optimize something else. Well, I don't think we need. But yeah, this is the parsing algorithm. I think there are ways that can be shorter, but I don't think they are that much readable, unfortunately. Usually if you go to solution, yeah, there are like 4 lines, I'm pretty sure, but most of them are like IJK variables are used. So you just stare at the solution for 10 minutes until you understand what is going on. I guess this one is much more understandable, at least in my opinion, so I'm not sure. Okay, we are done with the code string, and we are done with LeetCode problems at all today. Next time, we're gonna solve more, but now I'm gonna do some break, and after that we are going to implement our rate limiting solution using my favorite .NET. So yeah, not only design the system design problem, but also implement the system design problem, which is gonna be a bit more interesting, at least for me. So let's see, I'm gonna put some break right now. So break 5 minutes, and we are implementing rate limiter system design. Yes, it's not just script, it's plain text, so it doesn't show. Yeah, good. And now yes, see you in 5 minutes, and let's implement it. So I'm back. I just got myself a black tea. It's without lemon, so it's a bit shittier than usually, but still good enough. Let's come back to the concepts. So we're gonna implement the rate limiter. Rate limiter in our case is gonna be a bit simpler thing. So we will not create production service. We would emulate it with in-memory thing, kind of stop. You will see later. What we're gonna do is we're gonna implement rate limit API. API means that it will be a HTTP service that can reply and respond to HTTP requests. It will be implemented in .NET because first, I like .NET more than most of the backend languages. Second, it's my main language. And it has pretty much a lot of stuff for concurrency that we can use. Yeah, today we will talk a lot about some concurrency things that are not that obvious. Also, we're gonna implement it using the Redis, which is kind of conceptual implementation that you will get if you ask GPT for this. The rate limiting algorithm itself is pretty simple. It's called fixed window, something like that. So the idea is simple. You are splitting your timeline on the sectors, and you're telling that each sector can have at least, I don't know, let's say 3 requests per second. Whenever you hit force, you reject requests with 4 to 9 HTTP response, and just don't let this request go to production. So production will be kind of protected against this. This is the idea. We're gonna implement it. First implementation, we're gonna do it in memory. Second implementation, we're gonna do it through the Redis, which is much better solution. The problem with in-memory solution that in case we are scaling, because we want to support not like thousands but millions of requests per second, one single server, no matter how much you are scaling it, most probably will not handle 1 million requests per second, especially on the spike time. So it means you need to scale your HTTP service. Usually it's stateless, in our case it is. And in case of scaling, what will happen that if you're having this data structure in memory in every of the rate limiting, and it goes kind of randomly, so it's not sticky to the user ID or IP no matter what, you will go beyond your limit, because this one, for the user ID 1, it will have 3 requests. Then randomly it can hit this server, which in memory for user ID 1 has only 0 requests. So for this second, this server will get 3 more, and it's already 6 in total, which breaks our invariant. So in memory, rate limiting does not work well, but it well works for the in terms of defensive strategy. So let's say you want to protect yourself not from the user DDoSing you or from IP DDoSing you, but you want to protect your single deployment, so your single API, from kind of DDoSing. So you can defensively protect the API in the sense that you can tell how many requests this specific deployment can reach. Still, if you have one crazy user that sends you 1 million requests per second, other users would wait because he will get all the kind of throughput. Yeah, that's basically it. So scalable solution should use some data storage. Let's start. Let's check our questions also. So, sir, do you have some online resources for this system design concepts framework? Basically, yes. I'll show you right now. I think I even have the book downloaded at the moment. Yeah, so these are my last books that I've been reading. So there is designing data-intensive applications. Maybe it's not that much popular answer, because usually people are suggestion like cracking coding interview or cracking system design. I think I have this book as well. Economics and architecture in practice. No, I don't have this book yet downloaded, but there is another book. Let me Google it. System design interview book. Let me Google it. Most probably you've seen it, especially if you're preparing to LeetCode problem. Yes, this one. Yeah, I think I've read this one specifically. Is it Byte Go? No, it's not Byte Go, most probably. Maybe it was. Yeah, something like that. So I've read it and I didn't like it. I will be honest with you, I didn't like it. I didn't like the thought process. It wasn't that easy. It is good in case you already know how it all works, why some decisions are done in that way. Let me find the specific book. Yeah, I have it in my Google Drive. I will show you now. So design texture. Because maybe it's wrong book and I'm just putting shit on another book that I don't mean. Design refactoring. Oh yes, this one guys. So this is in my Google Drive. Second edition, this one that I've read. I didn't like it, to be honest. I prefer much more this book, which actually does not show you how to do a system design, but it shows you all the principles and knowledge with which you can do system design of every single system that you are asked. And Martin Klapman, I like this guy so much. It also shows you the thought process. So it shows you, okay, we can do this, but now we have this problem. Okay, we are solving this problem, now we have that problem. And he goes deeper and deeper and deeper. So you have full understanding. But unfortunately, this book is not well structured. So if you want to have some material in a way that, like in university or something like that, it's also not that good. Okay. Manfred code. Yeah, let's see what I'm nakostelyаю today. So first we are starting with, we should create our solution. So let's create rider instance. Yeah, and I will show you how to create API using .NET and design it. Yeah, I already did it. I'll be honest with you. I'm preparing before the stream whole week pretty much. So I have my repositories, which are, yeah, this one, distributed systems. I already have it. You can check the implementation straight away. If you want, I can paste the link to both YouTube and Twitch. Yes, you can already start reviewing how it's done. It's already Dockerized, so if you have Docker, just Docker compose up and run the load test, that's it. But we're gonna do it from scratch with thought process, with understanding of everything, and yes, like it should be done. So new solution. Yeah, and we're gonna do it. Okay, so projects. Let's put it to some TMP. Exactly. So it's gonna be our rate limiter. .NET 8, yeah, all the fancy cool stuff. New frameworks. What do you want from me? Console web, it should be actually web. Okay, now it couldn't find new .NET. It's okay. Solution send no. Create git repo, no, we already have git repo. SDK is good, console, add docker file, add docker compose file, but these are kinda useless. We would be rewriting it. So I was rewriting it with the ChatGPT anyway, so yeah, let's create it. Good. Good. Before running everything, let me just Explorer and open it also in Visual Studio Code as well. Why? Because I will show you later why. Projects. Good. So first of all, what I don't like about this is that it should be in the folders src, because there's going to be another folder called tests, and Docker file should be moved to the author layer. Yes. Yes, I guess it should be like that. Can be changed later, but whatever. Now it's good, our rate limiter is here, program, good. Now, since it's, not Microsoft, what do I mean? So, since it's just console project, so if you run it, it will just print our hello world. Now let's build the web services infrastructure for this. What the hell, what do you mean cannot load failed? Are you kidding me? Ah, yes, because we changed the directory. So due to this, we should open it again. Yeah, this one. Yes, let's reopen it. Yeah, the discussion is, does Microsoft paid for the rider? I was fighting for, yeah, so I will tell you the story before. So at Microsoft, I'm now on one of the backend services for M365. We have our project also running in .NET. It's pretty big, and we have one issue with NUnit, which is test unit, test runner, or test framework, I would say. In the way that Visual Studio sometimes ignores it due to some naming. It's like long story. And the problem is that it can be fixed with using ReSharper or using Rider. And I asked for my Rider subscription 1 year ago. I got it, but then it got expired, and then Microsoft couldn't provide me with this license. I don't know, like 1.5 months. I was asking them. It was very bad. This is pretty common problem. I don't understand, to be honest. It's trillion valued company cannot just give you Rider. Come on, it's $100. But I don't want to buy it because this one exactly is the free version, because I'm not doing any commercial programming here. We are doing it for learning purposes. To be more specific, we are doing it for system design implementation. So yeah, this is kind of learning. So yeah, answering your question, they did buy me the license, so I can now be happy. Okay, so first I would paste the boilerplate code that sets up our infra, just like that. Oh yeah, this one we don't want yet. Yeah, I would say this is pretty much default. What? Okay, this is interesting right now. It should have. This is default. Okay. Okay, fuck it. Let's just recreate new solution and put it as a web straight away. Just let's not waste time. So it's rate limiter web. It's also in our TMP, and we want web API. No Razor pages, just pure backend. Yes. No authentication, no Dockerfile, Docker Compose. Yeah, let's just, because I'm spending too much time on some boilerplate shit that no one is interested in. Good. Now this mother trucker has everything he needs. Yes. So this is default code for the API. And first of all, before you do anything, what I want to do is I want to add some controllers folder. And add our, I don't know, rate limit. Can I add controllers straight away? Yes, I can. Yes, I can. And it feels good. Let's say I'm gonna return some okay result, but why it's MVC? Oh my god. I think it should be this one. Okay, and yeah. I just want to make sure it actually works. Yes. Up. Swagger is enabled. No. Yes. Yes, it's enabled. Let's put it all the time. And our rate limiting controller, it's gonna be named. Let's say it's get method. So HTTP get rate limiter. Now I just want to make sure it works. Does it? Failed to load. Why it used this ASP.NET Core if it should be just .NET right now? I have no idea why. I don't understand why. So it's a bit strange. Let's try. Okay, it was just the problem with. Yeah, let me put it here. So here we are, and it didn't map our controller endpoint. So what I'm gonna do right now, of course, I will let the copilot to solve this problem. I don't wanna do it. Now real development starts, guys. The real one. So it should be map controllers, right? And that's it. Okay. HTTPS redirection, we actually don't have to. Is it all? Okay, and then we will remove this weird endpoint, which is inline endpoint. I don't like them as well. Okay. I'm sorry. Don't put, no. Add controllers, and do we need to map control? Okay, let's just. Yeah, that's what happens when you don't basically develop on the .NET for a long time. Yes. Good. Let's turn this off. Localhost 5278, what a weird port. Good, now it's working. Nice, we're gonna drop every single line here. Summaries and mapget. Yes, and restart the app. Good, is it still working? Yes. Yes, now it works. Cool, we can now start building our app. I'm sorry it took a bit longer time. Again, recapping, we are building a rate limiter that we designed previous time on our system design. We're going to implement this rate limit API, and the first implementation is going to be in the in-memory implementation. So if you know or you don't know, I'm not sure, the .NET Core has this principle, or I would say mechanism of dependency injection. Cool way when you can follow the solid principles and play with your dependencies in implementation. So the typical folder structure, I would say, according to the latest meta, I would say, is this one, Martin's, or how is it, Uncle Bob, whatever, onion architecture. So usually you have some domain. In our case, we don't have domain because we don't have any business rules. It's pretty infrastructure-based stuff. So we're gonna just add our application folder, which in theory will be decoupled later on to the separate project, so we can manage our dependency properly. And this scene should have our interface, which is gonna be named iRateLimiter. Why we need interface? Because we're gonna implement two different implementations of rate limiter. One is in memory rate limiter, and then we're gonna do Redis-based rate limiter implementation. Yeah, and this one should implement iRateLimiter. Cool stuff. Now, how it is supposed to work? So this method should have, this class or this implementation should have basically one method, which should either let the request go or throw an exception, which later will be converted to 429 status code, which is too many requests, identifying that you should calm down a bit with your requests. So we want to return task. Why? Because later implementation will be using Redis. Redis is network operations. Network operations is input-output operations, which are async. They can be async and they should be async if you don't want to break down your server very fast and to increase your CPU usage. So that's why we are using task, to be able to use then async await mechanisms to do asynchronous code. Let's name it allow. Oh, okay, it has already. Thank you, Copilot. So we have some kind of client ID, but I would say it caller ID. caller ID in this case can be caller ID can be IP, user ID provided from token, from header, whatever, it does not matter. So whenever we don't have some user ID, usually you can get user ID usually from JWT tokens actually in the pure backend. But sometimes if it's not pure backend, you might get it from cookie, for example. From header, it can be coming also like different other sources where you can get the caller ID. But if not, we would be defaulting to IP address, which you always have in your request. The next thing, we also need to know the datetime of the request. I will explain request time. I will explain why we are using it as a parameter and why we don't just dateUTC now, datetime.utc now straight away. Okay, this should be actually our interface. Exactly. So it's yeah, I'm sorry, it should be interface. Good. Good. Now this guy should implement this interface. Exactly. Now, how it's gonna be implemented? How it's gonna be implemented? Remember the picture. So we want to have every time for per caller ID, whenever it's user ID or IP, doesn't matter, we want to have some kind of bucket, and we want at each specific time, let's say we are in time here right now, this is our UTC now, and we are in this bucket currently. We want to know how many requests the user with specific ID already did, and whether to allow him to do more requests or not. Let's say here he did only 2 requests, it means we can allow at this specific point the 3rd request. If there is already 3 or 4 requests done, okay, 4 is not possible, but 3, then we should not allow, block it and return 429 straight away, right? Cool. How are we gonna do it? So first we need dictionary, because we need to maintain this window per user. So for sure we need some private, I would say read-only concurrent dictionary, and also yeah, we didn't build our structure. So there is another folder or module, infrastructure, and we put there our low-level implementations of our abstractions. This is the correct way of how things should be done. Here we have our thing, and I want, so what do we need per our user? So we need to store the information when this bucket started. So to know if we, for example, at this point, this bucket is already over, and we want to start another bucket. And we need to 0 our previous number of requests, these guys, to 0, and start counting again. Otherwise, we will be blocking requests that are actually should not be blocked. How this information can be, I don't know, expressed? I prefer actually to create some record or pub or class, doesn't matter. Let's do it in line, because this class will not be used in Redis implementation, so it's pretty much used only in the specific implementation of in-memory rate limiter. So let's call it caller information. Yeah, so for this one there is caller ID. We also will have actually, first of all, it should be record, because this is the meta. The meta right now is to use record. A difference between class and record you can check later in Google. So first of all, we need private integer. Actually, it cannot be negative, but let's put it just integer. Request count. This is the number of requests this caller did so far. And now, yeah, no, actually, let's move it. Caller info. You'll understand why we're decoupling it to the separate class later. So we have a request count, which is initially 0 when we create this guy. We should expose it to be able to read for statistics purposes later, but we don't modify. This is our property. It's cool. Then what else we have? We have caller ID, which, as I said, parsed IP or from headers the ID of the particular user, and we should have not the request time, because in this case we are not interested in request time. Request time we will always have as datetime now, but we are interested in the time when this bucket of the rate limit started, because we want to know when this bucket is over to know we can start the new one. So this should be I don't know, bucket creation time, something like that. And it should not be mutable, so the caller of this record should not be able to mutate this thing and to change it to something external. That's why we should bring the constructor. Should be actually below. Are properties first or constructor first? I don't really remember. Okay, doesn't matter. So we're putting here our string caller ID and yeah, date time. Good. Yes, we are initializing. Thank you. This one is not used yet, but it will be used later. And also caller is init only. Exactly. So these two cannot be changed, and this will be changed, but from inside. Why? I will tell you later. So now we have this method. We have some caller ID that we just parsed. Yeah, first of all, Copilot already suggests me, and it's pretty correct. So first we want to get the, it should be not rate limiter but caller info. We want to return our caller info if it exists. If it does not exist for this particular ID yet, we want to create it. So concurrent dictionary. Why concurrent dictionary? Because we're gonna have an environment where one single user, machine, or client can send a bunch of multiple requests. This is the purpose of rate limiter, to be kind of in front line of this and to protect from this. So it means we can receive like millions of the requests, and it means these requests can come from the same single caller, and it's concurrent requests. So we need to be very careful with accessing and modifying the variables that are concurrently accessed, because if we are not, it can lead to problem and wrong behavior of the code. So first of all, we're trying to create or get the caller. Caller info, we are going to do it like this. Rate limiters. Get or add. This method would either get the caller or create it if it's empty. And it will do it atomically, so we don't need to lock anything. We don't need to design some light synchronization mechanism. We can trust concurrent dictionary and .NET runtime that it will be done atomically and only once. This is guaranteed by the .NET itself. Now that we have caller, what we should do, we should actually increase the request number by 1. And then, if this request number is higher than the configurable one, then we can just throw exception. How do we know which is the request count that we allow per bucket, so per second in this case? We will load it from configuration, but for now, let's say it's static. So bucket request count, let's say static, it's 3 requests per second. We will load it from configuration later. And let's say that time window that we are doing, because we can have like 3 requests per minute, right? But let's put a bit more interesting case when we will have exactly highly concurrent environment. So we're gonna put limit per second, and then we will create in the end the load test that would spawn like 100 requests per second, this kind of stuff. So for now, let's say it's from seconds and it's 1, and we will load it from configuration as well. Now this caller info, we want to increment the variable, but we want to increment it atomically. And now my talk about concurrency starts. So let's say it's our RAM. So we have some RAM. This is your memory, right? This is basically the heap, but also you have your call stack, which is per thread, at least in .NET. So you have thread that can execute your code, and this thread has call stack. Basically it should be somehow like that. So call stack is separate thing. Thread also has a bunch of different stuff. And this is RAM. This is the huge heap where your like lists and reference types are stored actually. The stack, the call stack itself, on the thread, it stores only structs, so value types in .NET. Value types and reference types are different things. And value types are usually structs and all the primitives, which is double, int, boolean, enum, everything except string. String is still a reference type, but it's a bit special, so it's in heap. Heap. The problem is that let's say we have this caller info, which is class, it's object, right? So this object would go caller info to the heap, and we will have variable called caller. It will be on the stack because this variable is in reality is just pointer to this caller info. So it points to the heap straight away here. This is how it works. Large, yes. So whenever we are changing something in caller info, this thing does not change. And yeah, that's the thing. And if we reassign caller info to some another pointer and they would point to the same object, in case we change the caller info, it will be changed for both of these variables. So this is pretty simple stuff, I think. Now, what is the problem with concurrency here? Our caller info, it has primitive, but in this case, since our object on the heap primitive will be in the heap as well, so it has request count. And this is also kind of variable. And there we are. There is already a big problem with this in case multiple threads are trying to access this variable, which will be true. So let's say we got 2 concurrent requests from the same browser or same client, doesn't matter. Let's say from my IP right now, I created some bad application and it sends millions of requests from the same IP. So it means it will be like hundreds of threads that want to access this request count because it's same IP, right? At the same time. And this is where we have problems already. This is where we have problems. Because now how we're gonna update this variable, right? Because our usual update is, let's say, our request count is equal to 1, right? So how usually it's happening, your thread is loading request count, which is 1, and it does something like this. Request count equals request count plus 1, right? And do you know what is the problem with this statement actually right now? Do you know why it's bad? Why it's bad? We have 6 people watching us, so I don't think anybody would reply. So I will tell you now what is the problem with concurrency here. The thing is, if these 2 happen at the same time, and they are done by the different threads, this request count is equal to 1 now. They both read it as 1. They both increase it by 1. In the end, it becomes request count equals 2. And this guy also becomes request count equals 2. And we write them back to request count equals 2. But actually, it should be request count equals 3. Because we executed it 2 times. One time with thread 1, second time with thread 2. That's why people designed the atomic operations. These are special operations that have specific instruction on the CPU level that tells that please CPU do it in an atomical way. An atomic way of doing it is that when the processor sees atomic increment instruction, it's pretty simplified. It will increment whatever it is already in this variable plus 1. If it was changed, so let's say one thread is doing atomic increment. Now request count is equal to 1. Another thread starts doing it as well. Now both of them trying to increment. Let's say this thread won, and it incremented it by 2. So in previous example, our problem would be in this case that, yeah, our request count is equal to now because we read it before, and we will increment it to 2 as well, and yeah, it's bad. But atomic increment, it's like clever thing how you can do it. So you will increment it atomically, so CPU would reread the request count, kinda reread, and instead of incrementing it 1 plus 1, it will reread that request count is already 2, and it will give you 3. That's the concurrency thing, and for that there is specific kind of structure in the .NET called interlocked. This is lightweight synchronization mechanism that can synchronize multiple concurrent threads. So usually it works like that, exactly. So initially it requires you to put a reference to your variable. Why reference? Because that's how it works. That's how CPU instruction can work properly. But the problem is we cannot put reference to some field inside the class. Just by design, we cannot do it. That's why we are moving this increment thing inside the this caller.info class or record, whatever it is. And here we are implementing public void increment request count. Yeah, this one is not atomic, it's bad, so we are removing it. So first what we are doing, before we do that, I think the pretty much valid comment on this would be that actually we can put everything under the lock. So we can do something like this, lock. Let's say there is some lock object no matter what, and do our increments and stuff like that. In this case, it will work perfectly in terms of consistency. We will not allow unnecessary requests to go because locking in .NET works in the way that only one thread at a time can perform operations inside these curly brackets. That's why if only one thread can do it, there is no concurrency at all. But other threads, in this case, are waiting, and due to this problem, we will have bad thread consumption, I would say. And another problem is that it increases latency because this lock mechanism is deep level locking, which locks the thread on the operation system level. It can, it's hybrid, but yeah, worst case, it will lock thread on the operating system level, which we don't want to. So we are using lightweight specific CPU operation to do it in a thread safe way. Now what we want to check else. So we need here, I think we need data. Yeah, so first thing that we need to check whether we already at some point of the time where this previous rate limiting bucket is already done. So if we are at this point of time, and this is just 1 second, we need to start new rate limiting bucket, and previous bucket should be just dropped or set to 0. Because if it has 3 out of 3, this is the new bucket, we should allow the request. For this reason, we need to put a request time here. Cannot check if request time minus. Yeah. Yeah, and we should now pass our time window, which is in this case exactly 1 second. It will come from configuration, I said before. So if we outside of the window, we should just reset everything. So how we are resetting everything? We are putting our bucket creation time to request time. Sorry, it means we need to do private set here. Yeah, expose as less as possible. That's the design principle. Then once we did it, we are resetting hello. Once we did it, we are resetting our counter to 0. So we start from the beginning as it's new bucket window. And that's, no, actually not to 0 because this is the current request, right? And we're gonna allow it, and we just return. If we are still in the window, so in our case, it means, let's say this is the window and this is our request time. If we are still in the window, we are using the current request number that were already processed. So in this case, what we do, I'm gonna use volatile read. I'll explain in a bit. If volatile read, so volatile read is a specific also CPU-based operation, not kind of CPU-based. But what can happen, .NET compiler is pretty clever guy, so he can put some optimizations and put your variable values to the cache. So you might read actually not your current behavior, but also not behavior, not current value, but value cached by the compiler cleverly. Cleverly. And to omit this, how to say, to skip this optimization by compiler, you are using volatile read, which will for sure give you the not cached value, not optimized value. And if it's more than, well, we need to pass max allowed, right? Should be x max allowed. This is the number of requests we allow per bucket. So if it's more, then this is the interesting thing. Actually, I designed it in the way that we should throw exception. So this method is kind of ensuring request can pass. If request cannot pass, then, well, yeah, we are throwing exception. We will catch it later in the controller and throw 4 to 9 too many requests. So let's add our exception in the application layer, by the way. Rate limit exception should be exception. Yes, and let's implement basic exception pattern. Yeah, you should always do this, by the way. I think rate limit exception. I think actually in a nutshell there should be 2 more methods with different parameters because this is kind of exception pattern, and if you're implementing exception, do it in the right way. This somehow reminds me as a dispose pattern. So whenever you're implementing iDispose interface, you should implement pattern in a good way, so you don't do unnecessary GC calls or garbage collection. Let's get back to our color inform. Yeah, and if this scene more than max allowed, then we throw this exception. Not invalid operation, please. Rate limit exception. Exactly. Otherwise, we just increment the request count, we just let this operation happen. Now I go back to our in-memory guy, and this is exactly what we do. Yes, this is, well, this is pretty much how it should work. Yeah, one thing that we still missed here is this if. So, since we are in a concurrent environment, this if might be hit by different threads as well. So let's say this is our previous bucket, this one. Let me change the color. This one is our previous bucket, and we are right now, I don't know, at this point. And I don't know, 3 threads at the same time concurrently at this point. 3 threads concurrently going to this increment request count, they both increment. It will be, by the way, all previous ones, let's say in this one it was 2 requests, so they will increment 2 plus 1 plus 1 plus 1, so 3 times they will do increment. Then they will hit actually this if. They'll understand that they are already not in the time window. So this is thread 1, thread 2, thread 3. They both will start setting creation time to request time, which will be pretty much same. And they all will start to do this setting to 1, which is okay, because our limit would be set to 1. And in the end, the result after these 3 will be 1. But this is exactly the problem, because since we start a new bucket here, and 3 threads are concurrently resetting our previous bucket, it means that 3 threads just performed the operation, and we counted them as 1 operation. No matter how many more threads are coming here, in the end, if we don't solve it, worst case, we are having 1 as a request performed so far, but apparently there were much more requests. That's why, unfortunately, this specific case, we have to lock it. So we are doing usual lock pattern, which is to create some object called, it should be actually read-only object lock. Then use this object, and then perform this operation. In this case, once the first thread hits this thing and tries to reset, all other threads that already also hit at the same time this piece of code, they will not execute this code. They will not do it. Yeah, basically that's it. Yeah, so that's why. Now I think it should be pretty much done. And I think we're gonna just try to make it work. So to make it work, the beauty of the .NET, we just register our implementation. We are registering it as a singleton because this instance should live while the application is living as well, right? So it should be iterate limiter, rate lim in memory rate limiter, exactly. Now what it gives us that we can inject, once we register it in one DI registration piece of code, I would say, go to controller and then straight away eject, but we're gonna inject the interface. Read only, rate limiter. And here we're gonna do await rate limiter allow request. For this we need first we need somehow to resolve the caller info. I will show you now how I can do it. So caller ID, let's say we are taking it from query, which might not come. Let's simplify it, not token, not header, just from the query parameter. We're setting it to caller. We're trying to set it to variable. If it's still empty, we do fall back to the IP, which is caller ID equals HTTP context request. No, it is in connection property remote IP address. Yes, availability check, just in case it's not passed, but usually it will be. Okay, we have our caller, then we have request time. We should create it. So our request time is UTC now, and then we have everything we need. Yes, but now what should we do is try. We are putting it to try, and we are catching, guess what, our custom exception. It can be actually optimized to Boolean flags because exception is a bit slower than returning just Boolean flag about the result of the operation. But in this case, yeah, we are returning exactly 429. Thank you, Copilot. And that's it. Let's just try. One more thing, maybe to try to load it from configuration. So how did I name it? Bucket request count. So bucket request count, let's say we allow 2 requests per second, and another one bucket time span. It will be parsed, so every single second. Good. Now we're injecting here our configuration and loading it from here. Configuration. No, configuration, I need just configuration. Ideally it should be options pattern, but yeah, let's implement it just to be working. And now we are loading it from here, so how we do it? Get value, blah blah blah, and this value should be int. And same thing is happening here. Bucket time span, exactly. Good. Do I need to do anything else? I don't think so. Let's just try it. Yeah, let's try to start it. I will show. Okay. One more thing we need to implement. Let's say we have some production service stub. So in a real world case, in this case, when we allow request, here we would do, it should be actually middleware, which just drops all requests that are not valid, and then it lets the real request go. And in this case, what should be actually done? if there is valid request, we are not rate limiting it, it should go to production. But we are not implementing a separate production service for now. So we are creating the stuff which will emulate the production service and gives us a production service and it will give us the statistics. I will just paste the code from my implementation because it's already implemented there. And this production service is anyway then stop, so we're not quite interested in it. I will explain in a bit what this code does. So this production service has 3 methods. So it has concurrent dictionary, same way as our rate limiter have, and it counts successful and unsuccessful responses. Unsuccessfully are these ones that are throttled, rate limited basically. We needed to count and to see that our code actually works. I don't want to write tests for this, so let's just do it. Also, tests for concurrency cases, they are tough. So we are getting a timestamp, and then oh yeah, actually it should be this timestamp, I think, if I'm not mistaken. Yes, good. So we have our, yes, so we have concurrent dictionary, same way as we do in rate limiter, which stores the number of successful and unsuccessful requests per second. So long is the Unix based seconds starting from 1970 or something like that. So it will have another dictionary inside as a value, and it will store successful and unsuccessful requests done to production service for this second. So we just check if we have our rate limit in 10 seconds per second, we should have 10 successful responses. Everything else during this second should be unsuccessful because we drop it. And this is just the boilerplate code that adds it to the dictionary and increments it in a kind of also atomic way. So we're also using interlock here. Yeah, this is perform just a request that saves to successful, and this one saves to unsuccessful. And then we basically serialize this dictionary so we can observe it in our controller. And we expose endpoint for this. So let me also paste the endpoint here because it's boilerplate. It's not the real one. So private read only, production service, yes, no. Good. And now I need to register it in DI. Same way, so it also should be singleton for exactly the same reason, because we are maintaining the dictionary. And we don't need interface, let's not spend time on it. And now let's rerun it. Good. So this is our Swagger. This is our snapshot, this production service smoke. For now it has no response. Now let's say I'm user 1 and I'm starting sending, okay. We already got some error here. There is some null reference exception, let's see. Where it is? In memory, rate limiter allow request. So allow request in memory rate limiter here. Yes, sorry, I didn't initialize our dictionary. Should be this one. Yeah, so whenever it tries to resolve rate limiter per color. This dictionary, it fails because it's null reference. Now let's say once again. So I'm user 1. Hello world. Good. Good. Yes, and if I click too fast and it's like more than 3 requests. Yeah, more than 3, I think, requests, right, per, more than 2 requests per second, we are hitting this rate limit exceeded. And now our snapshot will show us, no, it will not show. Okay. However, it should show. Yes, because, I'm sorry, because. Yeah, so for rate limiter in the real scenario, we would do production service perform request. So request is performed for this caller and this date time. If we hit rate limiting, we are perform throttle request just for statistics purposes. And now, yes, also it should be awaited. Let's go. So our code works in a way that if rate limiter detects that this request is not valid, it should be throttled, then it will throw exception and perform request will not be executed even. So first checking user 1 request, checking. Yay, we have our statistics now. This is Unix seconds and this is one successful response. Now let me click a bit faster. So some of them are throttled, some of them are successful, and we will see later on the snapshot. So yeah, as you can see, like there are some race conditions, but generally speaking, we are really allowing like success only 2, not more than 2. Now let's perform something interesting here. Let's do load test. So let's spawn, I don't know, 100 requests per second. And yes, and see how it goes. So we're gonna put, let's say we allow, I don't know, 10 seconds per second, right? I cannot click 10 times per second. Like I really can, but it won't be that grateful experience for the you guys. So we're gonna do load test. How we're gonna do load test? Well, there is already a well-defined product called case 6 from Grafana, I think. See tests, yes. So we're just gonna paste the code here. I generated it with GPT mostly. So this default function is the function that will be executed per virtual user, VU, it's called. So we say that, let's say we have 100 virtual users, these are concurrent users, and there will be 100 times when this function will be executed. So whenever we start this script, this function is called 100 times. It will go to this URL, it will try to HTTP GET. If it's any of these two, it's successful, and then it sleeps 1 second, emulating that it's requests per second. So basically, this is 100 requests per second. One thing so that we need to change is the port. Yeah, I think the port and rate limiter, is this the correct one? Oh shit. It's different folder. Which folder we are right now? We rate limiter web. Let's change it. Yes, this is the guy we need. So again, load tests. Okay, 6 tests, yes. We are pasting exactly the same thing. Is it rate limiter? It's rate limiter. Now what should we do? We should go to this directory. Yes, and then execute. I have it in my readme. Should execute case6 native command. I already installed it in Windows because I did load tests before, so you're just gonna execute it. Is it working? Yes, it is. So now our snapshot only contains information about U1. U1 is user I was testing with. And now let's just run 100 at the same time. And while it's happening, let's try to check what is in our snapshot. Yeah, so this is our network, which is localhost right now, and you can see, okay, this is weird. It seems like we are allowing 11 access to. It's not right. It shouldn't be like that. So let's recheck. Let's recheck everything. So, let's maybe move this on top. Increment request count. Okay. Now, how do we increment request count? Interlog, okay. Okay, what is max allow? Let's just put some logging. Yeah, let's add logger. Yes. Yeah, this one and bucket. Request time. Then caller and request caller, exactly, request count. And then allowed is bucket request count, exactly. Let's rerun this mother trucker and rerun our load tests as well. It's user 3, let's say. So now snapshot is empty because it's in memory. Every time we reload, it will be empty. Let's start. Now we should see the logs. Yes, and we can see that, yes. Request count, it increases. Up until 100. Okay. Let's see the results. File. This is JSON. Okay, interesting result. This is exactly happening, I think, due to concurrency that we had. Actually, I was running benchmarks. It was much more precise last time. Much more precise, I would say. So request count seems like valid. caller is valid as well. Bucket time spent should be actually correct. But yeah, there is some imprecision, but in general it's kind of 10. If we change it to, I don't know, let's put it to 30, but also increase our load tests by, I don't know, 200 requests. 200 requests, and now try to run, and we will see the result. Hello, hello, solid goose. So is it done? Yes, it's done. Let's paste it. Yeah, so overall you can see, yeah, that due to some concurrency issues we might receive like 2-3 more requests than we actually have to, but this is happening due to concurrency issues for sure. And this is the trade-off of the system design in general, because you can have a safe version of this method, which is, I will show you right now, which is, should be this. So count safe. And how you can do it? Very easily. You just lock in everything, literally everything, by lock. So only one thread at a time can execute the block code inside. So you don't have this interlocked expression anymore. There is no concurrency inside the lock statement. And yeah, then you just do this. So request count. Okay. I think I understand what could be the problem before. Yeah, these images should not be returned. I think now it will be much more precise, but let's still implement the safe version, which will give you 100% consistency. So we have this one. Then what should we do? Yeah, if it's max allowed, if request count max allowed, then we throw. Yes, exactly the same thing. So we are doing exactly the same thing, but in a not concurrent way, because now whatever we put inside the lock, it's one threaded for sure. So we are doing it as a one sequential execution basically. And this one should give us the very good performance, but still I think I fixed this one. We don't need to return here. That was causing, I think, a bit more problems. Let's try to rerun still. Yep, so we are still using this increment request count. This one is not in use. Let's try to run our benchmark again. So it started. It's going, it's getting populated. Yeah, but still it has some kind of skew from time to time. Yeah, but in general, on average, we are getting not more than 30. Well, but there is skew for sure due to concurrency. And how we kind of solve this skew, we can use safe method. So I will show you right now how to. So instead of this one, we are performing increment count safe, which is fully locked. So it's fully safe to run. It should give us precise numbers. So exactly, sorry, should be max allowed like that. So it should be exactly precise. Yeah, now let's run our load tests again. Yeah, now no matter what you do, it will be exactly 30. Because now we are using heavy locking mechanism, which allows only one thread to execute the method, which is worse in terms of thread consumption, because multiple threads are just waiting to get the lock and to execute this statement. And another thing that it can use a heavy locking mechanism, which locks the thread on the operating system level, which is even worse, so you are losing latency. I don't have the proper load test to show you the benchmark, but yeah, this is the trade-off. So if you want to sacrifice, I would say, a bit with the latency, well, yeah, you will gain the consistency. If you want a bit better latency, you would sacrifice with consistency. You would get some of the requests that can sneak into this bucket, because yeah, without fully locking, I think it's not doable at all, or very hard to implement it in a like POC scene that we are doing right now. So yeah, I think for now we should stop. We kind of implemented it in memory scene. We implemented a load test. Next stream we will finish it and we will do it in a proper way. It will be much better than we did now. We will do it through the Redis, so implementing the fully this system design that we draw here. So we're gonna go to the Redis, and our rate limiting will be based on Redis. For the latency, it will have one network hop, and yeah, we will use the Redis async operations in this case, no in memory, and this will be done in next stream, I think. So yeah, thank you everyone for watching this stream. I think you enjoyed. I would appreciate any feedback. Yeah, for now I think we are done. Thank you for being with me. No big or not many questions were asked, so yeah, that's it. It was me, Andriy, and it was nice to stream with you guys. So see you.